This is Nick and Caleb simulating our 6th problem for digital simulation class, and we were tasked with calculating share price movements. So the following notation shows what we're dealing with, S being the share price at a certain time, the period of growth, the growth rate of the share, the volatility of the share, and then what we're going to be doing is calculating based off of Bernoulli random variables the share values increase or the share values decrease. Once we have these variables, we can plug them in to calculate again our increase, our decrease, and our probability of increase or decrease in the actual share. And again, we're looking at the independent Bernoulli random variable x sub I that we're generating. So we were tasked with finding the price at the end of each week. So that makes our time period 1/52nd, and we're given our mu and our sigma, or our volatility. And so we initialize the problem by entering these into MATLAB and then solving for our increase, our decrease, and our probability. Therefore, we get the following through MATLAB, which we calculated. So what we're looking at then is comparing our randomly generated number in a binomial random distribution according to the probability that we calculated in the number of trials we're looking at. Ultimately, this will determine whether we are increasing our share or whether the share is decreasing in value. And we're going to store these up with the following equation given and then plot these against time. Here's the plot for the share price movements. As you can see, very volatile and increasing and decreasing kind of rapidly over the weeks.
For part B, we're assuming there's 252 trading days within the year. Now we want to calculate what the max value of the share was within a 3-year period. As well, after the 3-year period, we want to calculate what is the loss between the max value within the 3-year period minus the value of the share at the end of the 3-year period. Additionally, we want to simulate 200 realizations of this and develop an empirical distribution to represent that. This portion of the code remains the same except for the trading days changes to 252. So the inner part of the for loop here, we again generate a random number to determine if the value of the share will increase or decrease. Then we want to capture if the value of the share increased, then we want to capture the max value of that. The outer for loop is the 200 simulations of this, and on the outside of that we want to calculate the loss, which is the max minus the value of the share at the end of the trading period. After sorting the losses of the simulations and developing a distribution of those shared losses, we can make the conclusive statement that half of the simulations, the max price within the 3-year trading period was equivalent to the value of the share at the end of the trading period. Therefore, there was no loss.